times or a million of times, each time you need to take a different instant, different random training instance and make slight weight adjustment. Until and unless you reach the class output, you should not stop the training process or weight adjustment process. Our objective should be for this specific input, I should get the class output to be 0, or for this specific input, the class output should be 1. For that purpose, we are going to update the weight every time or every instant with several iterations. So for algorithms for weight adjustment, that was being discussed in the previous slides. We discussed about perceptron learning rule, delta learning rule, Hebbian rule, Bitroff learning rule. Those are all weight adjustment algorithms. Now you can relate those concepts here for this particular example problem. So this is how we apply the algorithms for weight adjustments. And we train a network to identify the patterns or to identify or to reach the target. And coming to the next important topic, decision boundary. If it is a linear problem, if it is a linear statement, we do have two outputs, either yes or no. Based on the information or the data points, you can see we do have two different classes, yellow and the pink one. We need to differentiate the classes. So the decision boundary is actually a linear hyperplane which will divide the two classes. Divide the two classes, class 1 or class 2. Here from the previous example, we do have two classes, class 1 and class 0. Those are the classes. So this decision boundary will divide. So it has to divide it equally, but that depends upon your random weight assignment. And you need to adjust that. So every time when you adjust the weight, the linear boundary or the decision boundary would be changing. And we will be approaching to our main objective of differentiating the patterns. Finally, we reach a decision boundary perspective after multiple iterations, after several weight adjustments, we get this decision boundary with two different classes. All the pink or class 0 are grouped together, and all yellow data points, maybe class 1, it is grouped together. This is how we proceed towards the reaching of our objective. So if f of x is linear, the neural network can draw only straight decision boundaries. That is one major problem here. There are many layer of units, but if it is linear, we can go or construct a straight decision boundary. But if you are using a non-linear activation function, we can draw complex boundaries, but the data will not be unchanged. That is the difference between linear activation function and non-linear activation function. Here you can check out, with the help of straight line, it is very difficult for us to divide the classes. But with the help of non-linear activation function, that is famous example is sigmoidal function, tanh functions. Those are the methods for solving complex problems without the data unchanged. So multiple layer makes sense. So instead of sticking on to linear layers or linear classifiers, we'll move on to the multiple layers. So how this is going to happen? We are going to combine many layers of neural network architectures, and we are going to apply learning rules for updating the weights and learning the features. How it is learning the features. This is an example for learning the features. One second. Yeah, this is an example for this specific feature, for this specific set of features. What is the class 1? For this specific set of feature, what is the class? It is 0. This is how we have trained the network to analyze. So after rigorous training, after assigning the appropriate algorithms, we are just suffering with this type of decision boundary. So what would be the solution? do not work on multi-layer architecture, what would be our solution? Even though we are going for training or changing the weights, and there is a problem with this decision boundary perspective. We cannot achieve 100% accuracy in our performance. So now what is the solution? Along came deep learning. So we are going to a new way to train our network with the help of deep learning techniques, because we had faced some problems in neural network when we are handling complex or when we are handling non-linear set of data. There comes the deep learning techniques and how the training is possible. You have to train the first layer, train the layer first, then target the second layer. You know, as per our thorough discussion, this is the input layer, this is the output layer. So we do have 1, 2, 3, 4 hidden layers are available, and we are going to target each and every layer. So this particular area is trained first, then we are concentrating on the next layer, then the third layer, and finally the output layer. So individual priority is given layer by layer in deep learning techniques. Whereas in neural network, it's going to be a combined effort where we face some failures. So here it would be also known as autoencoder. The input information is preserved and it is encoded when it is moving towards the next hidden layer. It is forced to learn good features. So this feature selection method or feature extraction method basically happens in the first layer. That is how we can relate this with convolution neural network. Feature extraction, dimension reduction, feature selection, everything will happen in the first two layers, convolution layer and the maximum pooling layer. That is what happens there in CNN. We are going to learn the good features from the data set available from the previous layer. So input to the hidden layer, the data is encoded, and we are going to apply a standard weight adjustment algorithm to reproduce the input, and it is trained, and from hidden to output it is decoded. Finally we get the output with better accuracy. This forces the hidden layer units to become good feature detectors. Encoding and decoding will save or return the most valid feature informations. So immediate or intermediate layers are trained to be autoencoders. Final layer trained to predict the class based on the outputs from previous layers. So first few layers for feature extraction and last two layers is for classification. That is how we can conclude. That is how we can conclude with this particular topic. So just I have few words or few slides on deep learning techniques. Just as a continuation to neural networks, I wanted to throw a light on deep learning because other sessions will give you more insight on deep learning. Now let me relate neural networks with deep learning. That is what given in the slide. It's usually implemented using a basic neural network architecture. The term deep refers to the number of layers in the network. The more number of layers, the more deeper the network. You are going to include more number of neural networks and that will become a deep learning network. So we know neural networks contain 1 or 2, 3 layers, but whereas deep learning networks can have hundreds of layers. Excuse me. So the difference between NN, neural network, and the deep learning is given for your reference. We do have one simple neural network which has only one hidden layer. Whereas in deep learning, we will have hundreds to thousands of hidden layers. We do have hundreds to thousands of hidden layers. This is the difference in the architecture of NN and deep learning. One simple example, if you want to, excuse me for a minute. Sorry for the. So this is an example, a classification problem. We need to identify the type of vehicle or name the vehicle. So convolution neural network is applied. So this block will actually extract the feature, learn the feature based on the features. The fully connected layer, lastly, we do have a classification layer that will label the particular photo or image. So if you just check out, 95% of the features match with the database of car. So already we do have fed in the database with car, truck, bicycle. So you need to prepare the database according to your input set. So more number of information in your database will improve your accuracy. So 95% of the feature was similar to car pattern. So now car has been labeled or identified. So why deep learning? Why are we moving for deep learning? One important information is more amount of, we are going to deal with the more number of data. The amount of data is huge. And the performance will increase only if you are going to deal with the huge number of data set. As a researcher, you already know this information. Only with 10 images, we cannot train a system. We need minimum 100 images to train, minimum 100. But even then, it will lead to only 70% to 60 to 70% of accuracy. So to improve your data or to improve your learning accuracy of your system, we need to use large number of data set. So this large number of data set, processing this large number of data set is possible with deep learning. It is not possible with the neural networks. That's why we are moving on for deep learning techniques. So older learning algorithms, it cannot go on for good performance. There is a lack in the performance. That's why we are moving on to deep learning. What is the difference between these two? Already we know, we have discussed about this. Perceptron can be applied in neural network for linear classification, and for linearly separable patterns, you can go for perceptron. But for complex pattern, better to move on towards deep learning neural network. We have multiple hidden layer, so the process would be easy for us. What are the importance of deep learning or state of heart of deep learning? First of all, easy access to massive sets of labeled data. ImageNet, Pascal VOC are freely available. And from computer science background, all the faculty would be very well familiar with the data set. But as my background is towards medical data, I know some information about medical data sets only. So we do have access to all the data sets. Getting labeled data is very important in a research. That's how training would be good. Next one is increased computing power. This is possible only with high performance GPUs. And with this, we can reduce the training time from weeks to hours. For example, if you're going to work with your normal system, the training time would be 1 week. But if you're going to incorporate high computing GPUs, within several hours, we can complete the information. We have pre-trained models, AlexNet, ResNet, and we can apply transfer learning. Just modify the last layer, and based on that, you can improvise your project. And I wanted to show some top applications of deep learning across industry. We know about self-driving cars, fraud news detection, natural language processing, visual recognition, fraud detection, healthcare. These are the few projects I came across when I did a research on applications of deep learning. Handwriting generation, game playing, language translations. This language translations is very important. If you are visiting other countries, it is always good for us to have an app. If you want to ask something also, you need someone to help. So now, right now, we do have softwares which will translate the language, and the base behind this language translation is deep learning. And this is some triply based projects which utilizes deep learning techniques. If faculty members are working in solar radiation or solar energy prediction, we can apply deep learning, wind speed and solar radiation, power distribution. Then in grid management, smart grid management, there also recently researchers are working with the deep learning, electricity cost and load prediction, process monitoring and automation, fault detection systems, energy savings in buildings. Everywhere you can find out the use of this particular technique. This was one example I came across from the satellite images. With the help of application of convolutional neural network, the solar panel locations and sizes were determined. And this would be really useful for us. These type of projects can be encouraged. Instead of utilizing human power, we can utilize drones for collecting the training data set. You can utilize drones and you can come up with small projects related to these topics. Then for short-term load production, um, there is a deep learning neural network model which has been developed, and but it needs the past information, the historical load, like the past information is also necessary, and few parameters, few features whatever we record was temperature, load of hours, load of days, load of month, season, month, holiday. This as I discussed before, this convolution layer and max pooling layer is actually a filter which will extract the most important feature. We do apply striding for collecting the most important features. Then fully connected layer will give you the labeling, or it will classify the output. Then recently, this is one project, automatic driving cars. Deep learning is used to detect the pedestrians, and this will help to, sometimes the driver is not alert. Okay, so in that case, this camera can be interfaced with the driver alert system, and the system can alert the driver that there is a maybe in 5 meters of distance or 10 meters there is a pedestrian. So an alert system can be developed. This is possible with deep learning. This is one particular example. Right now, got this information from NVIDIA's data collection system. You do have automatic steering control. So this can be designed using CNN. So the input informations would be from 3 cameras, the left center camera and right camera. Based on these camera information, random shift and rotation has been decided, and based on that, we are computing the steering command. So the desired steering command would be the manual information. So based on the manual performer, we have got the information. Now we need to find out the difference, and based on the error, using the backpropagation weight adjustment, we are updating the weight such that this automatic steering command would be improved. What is the reference for us? The reference is desired steering command. So based on a discussion, what is the target output? Desired steering command. And the actual output is network computed steering command. Calculate the error and update the weight using backpropagation algorithm. So this AI software can be incorporated in cars, and there is one more example that is known as a Waymo vehicle. We are collecting information from a distance, maybe from a camera. The Google Maps can be interfaced with our car software to recognize the landmarks, to recognize the traffic signboards, lights, green light, red light, yellow light. That can be interfaced, and auto instruction to the driver is possible. So this is one particular diagram. Stop sign. Stop sign, it is interpreted to the driver based on image processing techniques. CNN is applied for this particular information. And in aerospace and defense, also deep learning is applied. Identification of objects from satellites that locates area of interest. Uh, Ship detection is possible. Then oil discharge control. This is one example from top view. This is an image of a ship, and we can also find out the objects present in the ship. We can identify from satellite images. We can just monitor what is actually happening in the sea. Navy patrol or Air Force, they can apply or use this techniques. And the basic process flow is given here. Image classification, object detection, semantic segmentation, instant segmentation. These are the few techniques. And we are familiar with this. This is another example. Language translation. Signboards can be translated. Next one is pixel restoration. Deep learning techniques can be when you receive a mass data set, a huge data set, you can apply restoration. Instead of going for a normal commands, you can just go for this type of deep learning techniques. Then in healthcare, in medical imaging, what are the data you require to perform disease monitoring or some screening techniques? What you can do, collect the information from the hospitals or some screening labs, ultrasound, MRI. These are all the few data sets. Then few bots, virtual assistants, chat bots are available. This is one famous app which has which will predict based on your skin, the cosmetics would be preferred, like suggested, and a series of questions would be given, and your skin type would be given predicted based on the inputs given by the user. The base is deep learning technique. Then what are the deep learning techniques? We are just talking about deep learning techniques. What are the algorithms and networks available here? You can see neural networks, multi-layer perceptron. These two are the base. From that, we can develop all these networks. Convolution neural network, recurrent neural network, long short-term memory, then stream CNN, fully convolutional networks. The pre-trained models available in CNN is AlexNet, LeanNet, faster RCNN, GoogleNet. These are the pre-trained models where you can apply transfer learning. That is why we can utilize all these pre-trained models. Because when we are talking about research, we cannot use the existing model and we can claim that it is my work. What you have to do, you can modify few layers from the existing pre-trained model and incorporate your ideas and complete the project. So now I've come to the conclusion. So I've given some information about the basics, neural networks. From neural networks, with this basics, you can move on to machine learning. So machine learning, it is also similar to deep learning, but not exactly same. You know the difference. Machine learning would be performing feature extraction, segmentation, classification using different algorithms, and the training time will be more. But when coming to deep learning, all these process, segmentation, extraction, classification would be performed by one individual network, by one single algorithm. So you are going to reduce the time, as well as with the help of GPUs, you are going to improve the accuracy. You are going to reduce the training time. That is how this travel from neural network has happened. I have done my MTech project using neural networks. I did my PhD in using machine learning techniques. Right now, my scholars are working with deep learning techniques. That is how the transition has happened. Like travel from neural network to right now, we have end up with deep learning. And right now, I'm working with this automatic traffic controlling bots, driver alert systems, self-driving cars. and a few medical related projects as well. So since we are good in this particular technique, we can explore all the areas. We should not stick on to one particular area. Since we know the technique, this technique can be applied to all streams, whether we belong to mechanical engineering or computer science or triple E&I. So all the problem statements are available that can be interfaced with the help of deep learning techniques. So this is here is where I'm going to stop, because my internet connectivity is also very poor, unable to show some um, simulations also. Maybe next time I can join with few other the session. I can just extend my session. Thank you so much for your patient participation. Thanks a lot for giving me this opportunity. I thank Dr. Chaya specifically, because she was the one who were in contact with me, who were communicating with me. Thank you so much, ma'am, for giving this opportunity to interact with all the researchers and faculty members. Thank you.
Thank you so much, ma'am, for your valuable information. So if can you share your mail ID so that the participant can, if any query.
Sure, ma'am, sure.
Yes, yes.
So this is my official ID. If you need my personal ID, the same ID @gmail.com. So personal ID and VIT ID is given. So kindly contact me for any research or any projects we can work together related to this area in deep learning techniques. And I've included few references. I'm sharing PPT with the coordinators. Maybe if the participants request, you can share this PPT, madam. I'll just mail the file to you so that for your references. So for beginners in neural network, we can go for these courses. Recently, I came across all these courses from NPTEL and from Coursera. I saw these courses. It might be useful for you. Just I'm sharing this. Thank you, ma'am.
Thank you, ma'am. Lakshman.
Okay, on behalf of the computer engineering department, I want to say thank you, ma'am. Thank you very much for your valuable guidance and sharing the very depth knowledge on a session. Thank you very much, ma'am.
Thank you so much. Now next session will start at 1:30. All the participants. Okay, madam.
Thank you, ma'am. I'm leaving the meeting. Thank you so much.
Okay, madam. Thank you so much.